If A and B are vertices of a polyhedron, define the distance DAB to be the minimum number of edges of the polyhedron one must traverse in order to connect AB. For example, AB is an edge of the polyhedron, then DAB is 1. If AC and CB are edges, and AB is not an edge, then DB is 2. If Q, R, and S are randomly chosen distinct vertices of a regular icosahedron, regular polyhedron made up of 20 equilateral triangles, what is the probability that DQR is greater than DSR? Well, I don't know what a whatever that is, it looks like. So let's talk about this using Euler's. You guys remember Euler's formula? That the vertices minus the edges plus the faces is equal to 2 of any of these kind of 3D shapes. Let's see what we can do here. So there's 20 equilateral triangles. So that means the faces, there's 20 of those guys. So I don't know what it looks like. So here's 1, here's 2, maybe there's a third one there. I'm just guessing what it might even look like, something like this. I have no idea, I'm just making this up. And yeah, some strange 3D shape like that. I just wanted to kind of draw a little sketch, but that's certainly not what it looks like, but just to get an idea. Okay, so the number of edges, well, there's 20 faces, each has 3 edges, because each of them are a triangle. And then, of course, in the end, you have to divide by 2, because each edge is shared by 2 faces. So if we just did 20 times 3, we double count. So you divide by 2. So you get 30 edges. And then subbing it into here, we get V minus 30 plus, 30 plus 20 is 2. So that means V minus 10 is equal to 2. So V is equal to 12. So the number of vertices is 12. Okay. I think that's some decent progress, but let's just see. Now we have to actually tackle this guy. What is the probability of that? The probability that the distance from some random vertices, right? Yeah, these are randomly and distinct vertices. So the distance between Q and R, wherever Q is and wherever R is, I have no idea. There's Q, there's R, I don't know, S might be here, who knows. The distance from Q to R, we want it to be greater than the distance from R to S. And I'll just call that probability P. And therefore, since they're randomly selected, if we did RS to compare it to Q and R, the other way around, that'd also be P. And therefore, they'd be equal when the probability is 1 minus 2p. Because all of these have to add up to 1, and I believe they do. Right? Because it can be either greater than, less than, or equal. Okay, so now let's try to see how we can draw this to make it have some sort of sense. So let's say the R is at the top, and then we're going to go, there's going to be, how many are there? 12. There's 12 vertices, right? 1, 2, 3, 4, 5, 6. So that this calculation was helpful. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then 1 at the end. So that's going to be 12 in total. So like this. And then this one. These are all supposed to be straight lines, by the way. Okay. So the distance, this is 1. The distance here is 1, 1, 1, 1. Now the distance to here, the cumulative distance would be 2, 2, 2, 2, 2. Like, for example, if I was going from R to here, I'd have to go 1 and then 1. That's why I put a 2, the cumulative distance. And the cumulative distance to this point, which is the other end, I guess, would be 3, right? Because if I went from here, that's 1, that's 2, that's 3. Okay, so we want to actually work with this guy here, and then we can calculate P. For it to be equal, the distances would have to be both 1 or both 2, because we've got two different, we actually have 3 different vertices. We have Q, R, and S. So for example, this is R. So if Q is here and S is here, the distances would both have to be either 1, both distances, or both distances equal 2. Yeah, because if you can't put 2 vertices there. They can only go in these guys or these guys up here. Okay, so let's do the math. So therefore 1 minus 2p, if you have both distances 1, that means you're going to, from these 1, 2, 3, 4, 5, you're going to choose 2. And I actually illustrated that with my Q and R placings. So from 5, choose 2. And that would take care of both distances being 1. If you want both distances to be 2, you'd have to choose from these 5. And therefore from 5, choose 2. And then add them, because you want or this or that. And then divide by the total. The total would be from the, not counting this top vertice, from the other 11 vertices, you have to choose 2. And that is 1 minus 2p. And then when you do all this math, you'll get down to 20 over 55, which in lowest terms is 4 over 11. And when you solve for p, you'll get p equal to 7 over 22. And 7 over 22 is choice. Let f be the unique function defined on the positive integer such that the sum of all the divisors of n of d times f at n over d is equal to 1 for all positive integers n, where the sum is taken over all positive divisors of n. What is f2023? Well, first let's explain what this means. We have the sum of all the divisors of n for this function d times f at n over d is equal to 1. So for example, we've got f at 2023, right? So 2023, first of all, let's explore that a little bit. So what are the divisors of 2023? They are 1, 7, 17, 119, and 289, and 2023. So if we apply that to this guy, it would basically be using these numbers as d's to sub into that. So it would be 1 times f at 2023 over 1. And then the next one would be 7 times f at 2023 over 7. Right? It's the sum, so you got to add them all. And then the next one would be 17 times f at 2023 over 17. And continuing just like that would be 119 times f at 2023 over 119 plus 289 f at 2023 over 289, and finally 2023 times f at 2023 over 2023. So that was the way you do it. And of course, all of that equals 1, so don't forget that one. Okay, so this is, I guess, at the heart of what we're trying to do, but we have to figure out the actual numerical value of that. So how do we do that? So what we have to do in this question is do a little bit of mixing and matching, meaning we got to figure out values for others and then kind of sub it back in. So first, before I do that, let me just clean this up a bit. So this is going to be f at 2023 plus 7 times f at 289, right, when you do that fraction. Then 17 at f at 119. Then 119 times f at 17, I believe. And then plus 289 times f at 7. And then finally 2023 times f at 1. So that is the cleaned up version of that original equation, and we'll just put a little star there to say that that's what we're going to have to eventually get back to figure out what we're trying to figure out is the numerical value of that guy. What is it? So the answer choice is obviously, they're numbers. Okay, so this is where we get into the whole nitty-gritty of it. So use the same function, and let's see if we can come up with other equations, and then hopefully those other equations will help me solve. So let's do this for n equals 7. And therefore the divisors of 7 would be 1 and 7. So that would make, if we applied it to there, 1 times f at 7 over 1 plus 7 times f at 7 over 7. So you're just doing the same thing. So this cleaned up is really just f at 7 plus 7 times f at 1. And that equals 1. We'll call that equation 1. And then we are going to do very similarly the same kind of thing, but this time for n equals 17. When you do it for n equals 17, by now hopefully you're experts. It would basically be 1 times f at this times n is 17, so it'll be 17 over 1 plus 17 times f at 17 over 17. So cleaned up, that would be f at 17 plus 17 f at 1, and that of course equals 1 applied to that equation. And then for n equals 119, that is going to be, we call this equation 2. And that's going to be f at 119 plus 7 times f at 17 plus 17 times f at 7 plus 119 times f at 1. And that equals 1. And then finally, when n is 289, that's going to be f at 289 plus 17 f at 17 plus 289 times f at 1. And there we go. Hopefully these ones will be sufficient enough for us to get the value for f at 2023. So let's see, if we take equation 4 and subtract from it 17 times equation 2, that will lead to f at 289 equals minus 16. So 17 times 2, yeah. And manipulating these equations again, if we take 3 and subtract from it 17 times equation 1, we will get f at 119 plus 7 times f at 17, again equals minus 16. And then if we sub these two findings into our original equation, which is up there, that guy, we will get the following. We'll have f at 2023 will be there. The 7 times f at 289, so 7 times minus 16. Then the 17 times 119, let's see here. If I factor out a 17, I will get, I think that I missed an f there, an f at 119, and plus 7 times f at 17. And then the rest, if I factor out a 289, I'll get f at 7 plus f at 7f at 1. And of course that's all equal to 1. So this is f at 2023. This we already got, 7 times minus 16. This will be 17 times minus 16 from here, I believe. And then this has 289. And this one is from here. That's just 1. And of course that all equals 1. So we've got f at 2023 times 7 times minus 16 plus 17 times minus 16 plus 289 times 1. And then when you solve for this, you'll get 2023. F at 2023 is equal to 96. And that finally is the answer, and that would be choice B. How many ordered pairs of positive real numbers AB satisfy that equation? So let's expand that equation and collect like terms. And when you do all that, which I'm sure you can, you will get b times 2a minus 1 squared plus 2a times b minus 1 squared plus 2a minus b all squared is equal to 0. So that means all of these are zeros. So that means that 2a minus 1 is 0, which means that a is a half. B minus 1 is 0, which means b is 1. And 2a minus b is equal to 0, so that means 2a is equal to b, or a is equal to b over 2. And that matches. So the only pair of AB that satisfy look to me like a half and 1, and since we only have one pair, the answer is 1, and that would be choice B. There's a unique sequence of integers a1 to a23 such that the tan of 2023 equals that. Whenever tan 2023 is defined, what is a2023? So what we're trying to figure out is this coefficient here, a2023, this guy right here. So how do we do that? Okay, well, what I am reminded of is this equation, which some of you know, involving complex numbers, that if you take cos times the I of sine of x to any power, there's a way of expanding it. And the power, of course, that we really want in this case is 2023. And by definition, this is the cos of 2023x plus I sine 2023x. Okay, and hopefully when we expand it, it will somehow, some way resemble that, and then we can see what the coefficient is. Okay, so recall, as probably every one of you knows, that the tan of anything is the equivalent of the cos, or sorry, the sine of something over the cos of that same thing. So in this case, it would be 2023. Okay, so that means that that will be eventually the form we want to get it into. And then if we use the e to the exponent I using 2023 as our exponent, that expands to cos 2023x plus I sine 2023x. And that, of course, is the equivalent of cos x plus I sine x 2023 to the exponent 2023. Okay, so now let's expand it. Let's expand and see what happens. So this is going to be 2023, choose 0, cos of 2023 x. And then plus dot dot dot. Well, the very next one would be 2023, choose 2 cos of x 2021, and then that's going to have an I sine x all squared, and then eventually you get to 2023, choose 2022, the cos of x, and then the sine I sine of x all to the 2022. And these guys here, these are the real terms, the real terms. And the reason those are the real terms is because they all involve I squared, and I squared becomes -1, right? You guys know that. And then we, of course, have to continue this. And then if you keep going with this, then you get into the imaginary parts, imaginary terms. And those would look like the following. They would be 2023, choose 1, cos of x all to the 2022, and then I sine x. And then eventually you will get to 2023, choose 2023. I sine x to the 2023. So these are all the imaginary terms. Okay, so we got that big long expansion done. Okay, so now what we really are interested in is the tan of 2023x. And that, of course, as previously defined, was the sine of 2023x all over cos of 2023x. So since the tan is this, sine over cos, and we want the sine is the imaginary part and the cos is the real part. So we put the imaginary part over the real part, and that would basically be 2023 from up here. Let me just keep those in the same frame. So 2023, if we were to figure out those numbers, cos of x 2022, and then times sine x, and then eventually the last one would be 1 times the sine of x to the 2023, and then that's all over the real part. So this was the imaginary part, and then this is the real part. So the real part is up here. So if we do those numbers, I believe it will be 2023. No, sorry, 1 actually. 1, yeah, 1 cos of x to the 2023. And then eventually you'll get to the last one, which would be 2023. Cos of x, and then I sine x 2022, and then eventually that I would disappear because it would be I squared, which is -1. Okay, so now let's figure out the coefficients here. I think I probably already did, but we make this whole expression look like this guy. And if you look closely, that has all tans in it on the right side. So we have to do that on this one. How do we get all of this to have tans? We'll divide top and bottom by the cos of x to the power of 2023, and that should do it, I believe. Yeah. Yeah. Okay, so then therefore this would be 2023. It would become tan x plus ... and then this would eventually become -1 to the 1011 tan of 2023, tan x to the 2023, I should say. And then on the bottom we'll have 1 plus ... all the way to 2023 times -1 to the 1011 tan of x. Okay, so now let's compare this. So now we have it finally in this form. Let's compare it to the original question. So this we got as tan 2023x, right? From up here. That's what that is. So then now we have it in this form. So it looks to me that this is the A1. I'm just trying to match these up. And then the coefficient before the tan of x to the power of 2023 is this guy, which I believe is, if you take -1 to the power of an odd number, it will still be -1. Yeah. And I think that's what we wanted, right? Well, we didn't want A1, we just wanted A2023, and that's -1. So after all that, we get C is the answer.